Good afternoon, everybody, and thank you for coming back. I hope you had a great time in your breakout sessions. I'm absolutely delighted to introduce Steve Brown. So Steve has held global CTO roles in both manufacturing and consultancy companies, and he's now the head of Digital Twins for SWECO Group, and he also has his own investment company. He's going to talk to us about Federated Digital Twins, driving out costs and creating value. Steve.
Thank you. Hi, everybody. So, I'm Steve Brown. Just get the right buttons. Yeah. So, I'm going to talk to you, aiming to get to this end about federation and value chains. But before I start that, I'm going to do a couple of little intros to some of the concepts. First, the concept of what SWECO does. And then I'm going to take you through some of the concepts explained to my customers to help them take away some of the confusion around what is a digital twin. So I'm not going to define a digital twin. I presume you know about it, but I'm just going to talk about the variants of those and then some of the benefits that we've been delivering with digital twins. Then I'm going to give you some real-world examples of digital twin projects that we have done at SWECO and that I've also done in my career on there. And then I'll go on to the subject matter of federation and how you use that to drive out things. Then I'm going to pose a little bit at the end, smart city. I'm going to talk a little bit about smart city. I've not done a smart city, so that's the bit that I'm talking about that's not factual. That's theory for me. So without further ado, SWECO. We are 20,000 engineers and experts. There are actually 21,000 of that, but about 20,000 of them are actually engineers in there. We are spread mainly over Europe, but also we've got things in Asia. There's got Vietnam and India there. We deliver all over the world, though, from those bases. And we deliver in these key areas of sort of buildings and city, utilities and industry, and then also transport. So, on to that first topic of, what are digital twins? So I'm going to start here with the scope of digital twin. And a lot of the clients that I start talking to and educating about digital twin, they really are confused because they get so many messages. And I thought this slide is designed to help understand why they hear so many different things. So the scale of digital twins, it goes all the way from these small little components that underpin almost everything we do, all the way up to the top there with, let's call them national digital twins, systems of systems in there. I've been involved in digital twins from top to bottom on all of those, and I'll show you a couple of examples that span that whole range there. Now, each of those spheres, of those areas of interest, those domains, they have different digital twins for different reasons. And that's where the clients start to get confused. So I think it's really important to define what your digital twins are, what their value is, and why they're there, but also how they fit into the next rung of the ladder or the next scale. How does the component fit into an asset, a pump set, for instance, in my example here? So that they can start to understand not just the value of your digital twin, but how it relates to what people do on a wider basis on there. But it goes beyond there because it isn't just these different levels of digital twins with different aspects. There are different parts of the life cycle. So I've simplified this. If you're an architect, there's maybe 12 of these in there if you use the Reba model, but I simplified this to just design, construct or build, and then operate and maintain in there. And again, each of these life cycle phases can use digital twins. And they all have the reasons for the people who are using them in those life cycle phases. And so you start to combine just these three that I'm showing here with these shells here, and you start to understand that somebody could be really confused because they've heard from somebody in the build phase who's working at a system level and somebody in the design phase or somebody at the asset level. And you get different stories. So it's helping them bring them on side. And then you've got tactical and strategic. So the tactical in the main, that's what SWECO do at the moment. They do tactical. And part of my job is to help move towards selling and delivering strategic digital twins to our customers. We have a lot of tactical. What that means is that the vast majority of our work is in the design cycle, probably about 80%. So when I say tactical, we're doing design digital twins. And in the main, we're doing them at a system level or the network of systems level, and also down into the process side. That's the majority of what I found, and I'll show you some examples of today. I say here limited scope, limited duration, and limited value. That doesn't mean they're not valuable. They're extremely valuable. We've got some fantastic use cases on benefits paid back to both ourselves and to our clients. It's just that the value is limited to a limited set of people for that limited duration that we use it from. We don't tend to hand them over to the builders, the constructors, the manufacturers. We use them for our own purposes, and we don't sell them to the client. That's in the main where we are. The exception is down at the bottom here. We have some, and my colleague Gustav is outside. He's demonstrating some that we deliver here. So we have some here. It's a small fraction of the amount of work that we do at SWECO, but I would say the majority of the external value with digital twins that we deliver is in here. Some of our clients, Castellum, Vasakron, we've got about 8 million square meters at least of property managed through the Twinfinity digital twins. So there's a lot of value to those then. But again, they're tactical. The key to all digital twins is being able to do it at a cost-effective level. That means you can then scale and repeat for this very low marginal cost. And what do I mean by marginal cost? Marginal cost is a financial term, an accounting term. It's the cost of doing it again. If you aren't heading to zero, then you aren't really going to be able to sustain digital twins. The reason I say that is that when you do your first digital twins, it's extremely expensive. The business cases almost never add up when you do the first one. They're proof of concepts. They're funded by research funds, by Vinnova, by the European Union. Or by your internal and R&D department. You have to get down to very low marginal cost in order for them to survive and be sustainable as tools and useful pieces of equipment. So the ROIs that I was talking about, return on investments. So we see, and these are quite conservative, but they're real. These are real. I've done them on my own projects, and I've seen other people do them, and other people do even more than I've done. So with the tactical ones, we're talking sort of 10 to 30%. Sometimes you can stretch that up to 50% ROI. And with the strategic ones, you're typically up at the 1,000% times minimum. And the reason for that is I'll come on to when I bring the next quote up from Gartner. I'll talk a little bit about why that happens. So the typical buckets of benefits come into these three, and I actually picked this up from one of my customers that I'm going to talk about, Siemens Energy. They talked about this in monetary terms of save money, more money, and new money. They're an OEM that produce gas turbines and things. And what you find here is that the OEMs and anyone who's producing assets used to constructing things and building things, they're quite good at saving money. They've been doing this without digital twins for a long time. And they're always getting budget cuts, you're always driving it down. So digital twins fall into that space. They help do it better. They do help in an awful lot of things that traditional methods won't do. But that's not where I'm really focused. The next level on here is actually, it's not about doing new services, which is over on the right. The more money and the more value is about being able to engage your stakeholders. So digital twins, if you do them right, really allow you to engage your audience so they can see what you do, where your magic is, where your value is. And just for that fact, you get to sell more. You get to explain more, you get more investment. Whatever it is that you do, it's a lot easier when you've got this visualization. If you come out and play, during drinks later on with the gas turbines I've got out there, you'll start to really understand how effective these immersive visualization can be. But it's not just about immersive. Any form of visualization that you've probably seen a few examples of today, it really helps you get more money and deliver more value without anything different than you were doing already. The new money and the new value, this is the hardest one. This is where people really struggle. So, and typically it's because they're not digitally mature. And almost all of the new services are around digital services. They're aggregating data that you can bring together because you've got a digital twin, and then you can sell that as a subscription to do interesting things on there. And once you've got to that level, you can then start doing the what-if analysis and the scenarios that you might have heard about today. So you get much better at doing this innovation, proving that things are working virtually before you spend a lot of cash building them physically. So they become really interesting tools for the innovation. And probably one of the biggest use cases that I pursue, certainly in the industrial world that I do digital twins in, is this reduced time to market. I've shown clients how you can take a third off the time to market with first-of-a-kind products going to market because you can do this virtual provisioning, as I call it, the ability to bring everything together virtually before you actually build. And this quote I really like. I mean, Gartner made it in 2019. I think it still stands. I haven't seen a better quote yet. But it talks about that, digital twins, they are valid. They do give this situational awareness. They do help you save money already, better than existing technologies. You can do it without the digital twin, though. There is no other way, without a lot of effort. Digital twins are far cheaper at helping you bring together data across your entire organization or across the whole ecosystems I'll talk about later to really help you automate. And it's the automation that removes costs, that drives you up towards new digital services, the ability to really make these 1,000% that I talk about up there. Because you change your business model, you change your approach, you remove non-competitive cost, and you've really focused on value-added service. The building blocks that I typically play with are around here. So SWECO, very strong in design and simulation and domain expertise. That's what we bring to most parties, we interact with all of the other areas. So whenever we're doing asset-based digital twins or building digital twins, you need to be looking at the control systems, the building management systems. You need to be able to have the feedback from sensors. So you need to work in partnership with experts in those fields. We have those experts in various different places. But the thing we've got the most of is the designers and the simulators and the domain experts. And then we've got the ability to then take this data you bring together and add this more value. The ability to do your advanced analytics and your artificial intelligence on there. And what we're playing with at the moment is this sort of boundary between the probabilistic models of OpenAI and ChatGPT type things and the deterministic of the engineer and the science of building things and manufacturing things and designing things in that space. And then, of course, as I've just said, you've got to then be able to represent all of your data that is the digital twin in a really good HMI. And I've seen quite a few good examples outside. So we typically partner with there. You see some examples, we do have internal capability, but we tend to partner with people to do those different things. So it's all about partnerships. This is an interesting one as well for my clients to understand, and that is that the effort and the value are not directly proportional. It's a lot of effort at the bottom when you start, a lot of effort to get going. And the number of use cases are quite small. You've got to go through that phase. There's no shortcut. You have to go through that phase because you've got to go through that first phase of gathering data from your silos and bringing it together. And the various mechanisms we'll talk about later and some mechanisms I've heard about there. But once you get up there, you start to join your data. Once you start to get up, and if I can work out where the pointer is, once you start to get up to about level 2, you get into network theory. And network theory is that the value of the network is proportional to the square of the nodes in the network. And this is why it starts to get easier and easier and you get more and more value as you go up. Because you've already got the data, it's already aggregated, it's already correlated, it's already brought together. It starts to become easier then to do this what-if analysis and start to enrich it and put this two-way interaction and build algorithms that then work within it. I've never gone up to a fully autonomous operations. I have 2 projects ongoing at the moment whose ambition is to get to fully autonomous. I've not personally delivered yet, but that's where we're all headed. Again, back to what Gartner said, and back to that sort of 1,000% return on investment. The good news is, once you've gone through that bottom layer, it gets easier and easier as you go up. And if you remember what I said earlier on, once you've done it once and you go to a new set of digital twins in a new domain, it gets easier to repeat because you've got methods and tools and capability to do it the second time a lot quicker, a lot easier, and a lot cheaper. Just a few examples that we've actually done. These are design phase digital twins. Bear in mind that's mainly where we're involved. So this was one of those ones that we bought in Frenea. We bought this last year as part of an acquisition. They're doing some really interesting things with VR and using BIM data and pulling it down. It's quite manual. They've got repetitive sort of libraries for being able to do some of the VR sims. But it's all about safety, a lot of what they do. And does this work? Does it fit? And doing it before you start to build anything. They did the Stockholm road tunnel, the longest tunnel in the world, I think. They did the simulations on that here in Sweden. And then we've got other ones where we're working with tools like iTwin from Bentley, alongside of ProjectWise. We've done light railways in Bergen, and we've done manufacturing plants all over the world, where we use this alongside of the BIM to visualize and do clash analysis and BIM coordination and all sorts of things like that. And the use cases here, some of these use cases are greater than that 30% I talked about. There's a lot of saving. These ones we do for ourselves. This one we do for clients because it's all about showing the clients. But these ones we've done for ourselves, so they don't get sold to the client, which I think is a shame. It's part of my job to help them. Here's some more in the operate and maintain phase, so right at the end. SWECO don't build anything. We might be the engineering partner that helps the engineer keep the constructors under control and keep them aligned with their requirements, but we don't do any building ourselves. So some of these are built with technologies built on, say, Microsoft Azure IoT, and Azure Digital Twin, but self-coded. That's here in Sweden. And these ones are interesting. This is more to do with a model-based digital twins, where we've got models of the sewage system to avoid overflows. That's ongoing at the moment. And these are one of the ones that have got an ambition to go fully autonomous. And then we've got a couple more. Again, these are different aspects of the Twinfinity product that we've got outside, where this is sort of around Castellum and Vasakronan. And this is for some manufacturers of equipment that sell into the facilities management space. This is my background. I'm a mechanical engineer. I do a lot in industry, but I joined SWECO so I could do more in the smart city space. So again, these ones I'm going to talk a lot more about this one later on. So these are ones where we're doing full life cycle, end to end, from the design process through to the operate and maintain phase, and bring in a lot of capabilities. This is another one that the Twinfinity guys are just getting into. This is just starting. This is a partnership with Traffic Verket. This is where looking at IFC formats and BIM formats and seeing how a huge organisation like Traffic Verket can build up its maturity to deal with this stuff. So it's mainly about them assessing their own capability and looking at twins based on IFC and BIM going forwards. So we'll expect some interesting news out of that as we go forwards in the next year. This one's interesting. I'm going to play this one. This is another partner of ours, Digital Twilling, who are also working in our largest clients, as you'll see in a minute, which is Traffic Verket and the train operators, and also LKAB. So they've got this federated digital twin based on all of these different operating companies that you can see here, sharing their data, and Traffic Verket sharing their traffic, their line data and their trackside asset data, to be able to then put interesting use cases on the top. So this one's a supply chain, which is actually what they call Malmbanan here. This is the iron ore. It's part of the largest supply chain for iron ore by boat in the world. And the federation is between the operators that are also operating that line, between LKAB themselves, and also between Norban and Traffic Verket, and then the ship companies, where they ship the stuff out in this thing. So it's got some very interesting results, and LKAB are happy to talk about that. This is one that builds on top of what they've done with the operators and traffic Verkit. If you've got a modern Volvo built, here Trollhättan or in Gothenburg, then you can get this data directly into your car. This is one of those federations where all the operators are sharing their data to avoid collisions with people on these unmanned crossings that are in there, using geofencing technologies and with the train operators sharing their location, not the precise location, but where they are in relation to the geofencing that is on there. There's some more interesting ones coming out of this one that are worth even more money. So apparently a bigger problem is collisions with animals rather than collisions with people and trains and cars. That doesn't happen so much, but collisions with animals happens a lot and causes a lot of damage, especially as you get further up north. And then you've got these other use cases around making smart trains and adding more sensors to existing assets and then using that to do these algorithms. So now I'm going to get on to the main thing, federation. I'm just going to check the time there. So federation around these things. There are 4 types of federation. I can't talk about all of them, but I'm going to talk about federated data within an organisation and across the supply chain between organisations, and how that then leads us to be able to have the possibility to do federated digital twins, and then after that towards federated learning. Federated learning is something where you're sharing models and sharing learning, but not sharing data across to each other. I can't talk about that because I haven't done it yet, but I'm very interested in that. So, how do we deliver as organisations? So we deliver along a value chain, and the value isn't realised until we get to the end. That doesn't mean all the value is created at the end. We create the value all the way through that, but the value is realised at the end. And typically in a commercial organisation, as well as in government organisations, you have silos. These organisations grow and do their own thing, and they really focus on what they do. They don't really support the whole reason of being. These silos get in the way, these gaps between organisation. You really have to start to fight. So value chains are what I call this discontinuous set of processes. They drive cost massively in all sorts of different ways. And so therefore, for me, the reason for a digital twin is really for you to be able to paint an accurate picture of the state of that value chain, so that you can then really understand where it is and make decisions along it based on actual, accurate data. And then once you've got that actual picture of where you are today, it's then to do something about it. It's to remove that discontinuity. And you can only do that by sharing models, sharing data, having good, accurate pictures as you go. And therein lies the problem. So when I do digital twins, this is the first thing I recommend to clients. We don't twin the asset, we twin the process. And what that means is that if you twin the process, everything that you produce with that process, you will get a twin of for free. If you twin the asset, it's out of date almost by the time you finish twinning the asset. If you twin the process that designs, builds, and then operates and maintains the asset, not only will you have a sort of free design digital twin and a free construction digital twin, but you'll then continually have the digital twin updated by the very processes that it's there to support. So this is really, really important for reducing the cost of doing twinning. And the way you've done that, I thought I was going to be the first person here talking about this, using this alien word, ontologies. I was very happy to hear lots of other people talking about ontologies. Nobody really went into the detail though. So I'm just going to talk a little bit about that one before I end. So within an ontology, you have data schemas, not data models. In my opinion, data models are the root cause of all evil to do with all those silos. People argue about data models, and my data model is better than your data model. So we can harmonize, but you have to switch to mine. It never leads to a good outcome. Data schemas aren't about that. Data schemas are about describing the semantics of the data without getting too worried about the specifics of the format. Semantics are where you can start to put first-order logic into your descriptions, if then else. That allows you to have a lot more than just a taxonomy, for instance, of hierarchy of words and labels. It starts to allow you to put in the purpose. Why am I doing this first? Why does this thing exist? So, with this, we can then capture something that's not normally captured. It's something that you learned. It's the tacit knowledge in the engineer's brains. We can encode that. So we can really describe a whole domain of interest. And once we have that, we can use the inherent property of ontologies called class and inheritance. What that means is I can have a class called coffee machine. I've got a digital twin of a coffee machine. You have a class of coffee machine that all other coffee machines inherit. It's quite simple. You need water, you need coffee beans, and you need to pour one on top of the other, and then you can then brew a coffee. This is what all coffee machines do. They can all inherit that. How they do it is slightly different, which is why you have different classes. You can have the manual class, you can have the automated class, you can have the ones where you've got a percolator. There's all sorts of different classes that inherit different properties from that main level. And there's no limit to the number of hierarchies you can have to describe them. These make it very, very easy to describe whole domains of interest, like processes, and cover vast ground very quickly in a very repeatable way. So how do you use them? I'm going to miss a little bit of the magic here, and that's how you synthesize them. But what you need to do is have these micro-ontologies, or small focused ontologies, on the particular domains that match whatever your organization is doing. So typically, certainly in a manufacturing organization, you will have a designers. Designers produce what's called a partonomy. It's the structural data, the bill of materials and the 3D models. And whether you're using something like NX and CAD, or whether you're using a BIM system, you're producing structure. You have sourcing within the organization. They really focus on buying stuff. Most people don't make the equipment they design. They do contract manufacturing and then assemble it. So your supply chain is really important. They're going to purchase what you've designed from somebody. And then you've got your control systems. When you've assembled it all together, how does this machine work? One of the important things that you can do within an ontology is describe the concept of what it is we're doing with this system. Why am I even making this machine? What is it going to deliver? What's its value? Once you've got those ontologies defined and you synthesize them, you can then create a graph database. So you've heard them described as knowledge bases. But underneath a knowledge base, there's a graph database. And graph databases are absolutely essential for storing relationships. Relational databases, interestingly enough, or ironically enough, cannot store relationships. So they shouldn't be called relational databases, but they've been around a while. I'm an expert in relational databases. It's where I started my career. And when I came across graph databases about 6 years ago, my eyes were opened. All the problems I've ever had with hierarchical databases are now solved with graph databases. Basically, it's the ability to put these intelligent relationships in them. And what you're doing is that you're instantiating the structures in the graph database from the ontologies. This is an abstraction layer. That means you can create a data-driven mesh. And that data-driven mesh is elastic, meaning it can expand and contract and change quite dynamically as I introduce another set of ontologies. Or maybe I've got a whole bunch of SCADA systems. So I've got different ontologies for them. Or maybe I've got a whole bunch of people doing different designs in different ways, so I need separate ontologies. You can then apply them to the existing data and bring in new data and create this elasticity, so elastic knowledge graph that you put into there, that then gives you this real capability to match actual reality. And interesting, in actual reality, everything is connected. We're quite governed by process. The systems of record that manage our processes are not connected. This is why we've got those silos. This is why it's very difficult to do. So you've got to do something a bit different to bring them together. And ontologies in graph database is that difference. Sorry, just watching time. So just to look at that in action then. So with that capability, you can start to look at having these databases, these federated databases built within organizations, and you can have these combined ones that span the whole organization. And you can then take that further and have them across separate organizations. And you can do this in many different ways, depending on what it is you're trying to do. So in this instance, this is more like the warning for train example I showed with digital twilling, for instance, where these parties are sharing their data to a separate party, not for their own commercial gain. They're doing it for a joint interest, and that joint interest is to avoid crashes. It's not in their interest to have crashes. Not even if it's not their train, it shuts the line down. A lot of the lines inside of Sweden are single-track railways. If there's a train crashed, they aren't running their trains. If it's a really big train from LKAB, it can take the whole track out, as it did a year and a half ago. So you really don't want this to happen. So you're sharing data because you've got a common interest, not for commercial gain. You can also do this for commercial gain as well. This works when there is this shared interest. Government with open data can do this sort of thing. Then you've also got this particular model where you're essentially aggregating along the value chain so that by the time you get here to the customer, you've got this digital twin that's built up as you go from all the sub-digital twins or just the federated data. You don't have to have digital twins at each level, but you've got to be able to federate the data along there. This gets a bit more difficult. So this really only works when you have a prime contractor at the end that has contracts all the way down this chain to get this data. If you don't have the contracts for the data, you aren't getting it. And they are only interested if they can sell it, or if it enables them to have more money, sell more, some competitive advantage. So it doesn't work in all organisations. You can mandate for this. Governments can mandate for this, but government doesn't really work like that. So whenever they do that, it tends not to work very well anyway. So this is primarily a sort of private way of working. So that brings me on to the final couple of slides. What about smart city digital twins? Let's look at what a city is. A city is quite interesting. It's a bunch of people who live there within the boundary. They live, they work, they study within that same boundary, sometimes within the same building as other people. It's a bunch of autonomous enterprises that are also in this shared boundary. The only thing that controls them is a common law. And then you've got certain organisations that are charged with at least governing some aspects of it, in municipalities, Trafikverket. But they only do some of it. So where do you even start with a smart city digital twin? Who's going to buy it? Who's going to give you the money for it? And I'm excluding here EU funding, because as I said earlier on, this is all about R&D. Who's going to pay you to build it for Gothenburg? I mean, the Gothenburg city started, there was one outside. It's interesting what they're doing there, but they only cover a part of it. Anybody been listening? Where do you start? That's the answer I wanted. I didn't bribe him. You start with what you've got, the processes. There are all sorts of processes. Urban planning, big love, building permission. There's all sorts of processes that we can start with to cover the bits we have got. And as you saw earlier on, we don't have to join them all up earlier. We can federate. We can join them up later. But what about the rest of the people that live there and the organisations that are autonomous? How do you bring them together? Typically, people and organisations do not do anything unless they've got a common interest. So there's a lot of open source stuff going on where there's a common interest to do something. But most organisations are not that interested in that sort of stuff unless they're government organisations or educational establishments. Most companies want to do it for commercial gain. So there are some new technologies, but I've not done, this is the bit I've not done. But I'm very interested in this. I've been watching this space. I've been watching blockchain for quite a while. And in particular, when somebody mentioned it earlier on, smart contracts. Smart contracts are really, really interesting because they allow you to consume. You can contract for these services and you can, this company can contract that company for their data. It can add some value and then sell it to somebody else. That can all be done in smart contracts. Why are smart contracts so important? Smart contracts are built on blockchain. Why is blockchain so important? It's irrefutable. It's non-repudiation. If you had a smart contract and you bought it, you bought it. You can't go back and say, I didn't buy that. You bought it. It's there, black and white, in noughts and ones. And that means that the settlement is automated. You bought it, you're paying. And this is a really interesting area of how you can start to monetize data. There's these organizations that are starting to be created called DAOs, these decentralized autonomous organizations. This is the community of interest that are doing stuff. Yeah. So I'm going to leave you on there, and we'll take questions later on.